We have successfully analyzed everything there is to know about the relative motion of these three contacts shown here. We figured out how they're moving, what direction they're moving, when they're going to get to the closest point that they'll be at. But if we want to go any further with this, if we want to understand, if we want a better view of the situation, and if we want to maneuver to avoid the situation, because we know there's going to be a collision here, what we need next is to determine what their true motion is. So remember, all of this is relative to us. Contact A is not facing this direction. It's not facing, what did I say, it was 194? Yeah, it's not facing 194. It's heading some other direction. We don't know where. But with our motion and their motion combined, the relative motion line we get out of the vector triangle is pointing this way for contact A. It's pointing this way for B and this way for C. So if we want to find what their true motion is, where they're actually headed, we have to reconstruct that vector triangle that we've been ignoring for the time being, but we went over in the past. And bear in mind, the most important thing you need to understand the vector triangle is, or to be able to reverse engineer it, is our course and our speed. Because right now we have the relative motion of the body of the various objects, but that's all. And if we want to find their true course and speed, we would need to combine the relative motion with our course and speed. So I haven't placed it down just yet because I wanted to focus on the relative motion first. But technically, the first thing you do in a problem such as this is you record your course and speed. And even when you're just monitoring the contacts, you have your course and speed plotted down just to have it ready for when you're eventually going to need to do it. We set it as a vector coming out of the center of the scope, pointing whatever direction our heading is. And then the speed in this is going to be scaled on the 5-to-1 scale. I'll get into the differences between Navy and Maritime momentarily, but if I remember, they both use the 5-to-1 scale just to plot down your speed at the very beginning, just as like a bookmark, just to keep it there at the ready. So for this problem, let's say we're on course, I don't know, 255 and a speed of 15 knots. So firstly, we're just going to plot our course here. There we go, that's 255 right there. And we're going to draw it out with a length that is equivalent to 15 knots. So we're going to come to the 5-to-1 scale, which is off to this side. Maritime industry might use the 3-to-1 scale, I don't remember. But we'll stick with the 5-to-1 scale for these purposes. If it's 3-to-1 when you get into class, it's an easy fix. So we pick out 15 knots on this scale. And we plot it here, and unsurprisingly, 15 knots is equivalent to the third circle out from the center, because 3 times 5. And now we're going to actually label this like we did our vector triangle. So we're going to place in the center of the scope E, and we're going to place at the end of our speed vector R. So we know that this is our course and speed right here. And again, when you have a problem, when you're going to start a MoBoard, this is the first thing you should do. Even before you start, or I don't know, if you want to, you take out your paper, you record their M1 positions, you plot them down, and then usually while you're waiting from M1 to M2, that's a good time to just put down your course and speed. But it should be one of either the first or the second thing you do, just to have it at the ready. It's going to help you kind of visualize what's going on here. Because up until now, we were just a dot in the center and everything was moving around us. Now we kind of have a better idea of how these things are moving together. This doesn't mean that we're moving this way and it's going to pass the stern of us. It's still going to collide with us, and these ones are going to pass wherever they pass. But it does mean we can kind of visualize our motion in relation to the others starting now. And from here, I'll make the triangles next video, because from here, we're going to run into a problem of the difference between the Navy and the maritime industry, or at least everyone in the maritime industry that I've worked with who taught me how they do it, is things become aesthetically different between the two from here on out. If we want to determine true course for these contacts, we're going to have to build a vector triangle by comparing our ER vector to our RM vector and then finding our EM vector as a result. However, for whatever reason, the Navy, when they do their MoBoards, they construct the vector triangle in the center of the scope. And all of these contacts are going to have their own vector triangle, and it's all going to be made in the center of the scope. Whereas in the maritime industry, or at least at the academy, or at least my teachers, who knows, they would perform it on the M contacts using the M1 to M2 vector as our RM vector, and you would make a separate triangle for each of them. Ultimately, there's no right answer between the two. Each of them are equally valid. However, there are advantages and disadvantages to them. And at this point, I think the Navy way is better. I think it's more convenient because you ultimately need to do less work. However, the advantage of the Merchant Marine way might be that it allows you to do everything in the same scale, so you don't have to convert between different scales like you would with the Navy way. In the next videos, I'm going to actually recreate an exact duplicate of this setup here, and I'm going to do it, have this one be, or whatever, I'll have one of them be Navy, one of them be Merchant Marine, and show you the difference between the two, and show you how ultimately they're doing the same thing, but what the differences are. Honestly, I think you'll come to the same conclusion that the Navy way is preferable, but we'll see. The whole point of all of this is that once we can determine the true course and speed of all of the contacts, A, we can figure out how to maneuver, and B, we get better situational awareness before we even get to A, of our circumstances. We can kind of analyze things within the context of the rules of the road. It's not something I've touched on yet, but you know, the 90% of the rules of the road are to avoid collision. And this is how we actually practically apply what the rules are telling us to do. If we need to come and pass a contact astern, using a maneuvering board or a radar transfer plotting sheet is how you plan out how to do that. Or you could just do it by eye. But let's say you're in restricted visibility. This is how you're going to figure out how that actually gets done. Now, I am not going to make a series of videos on rules. I don't want to do that. It would be a massive pain. Just focus on your classes for that. But they will become relevant here. And I'm assuming in most cases, you've already learned rules if you're at the point of radar. So we're going to be relying on that too.